Good day, class. Today we're going to go over the test review, and I wanted first for you to try it out, and then anything you either missed or want to just double verify, this would be great to go ahead and do that. Now let's go ahead and read question 1. It says, use the method shown in class to complete the assignment. Show all work by hand. And it says, for the given function, identify its function family, write the equation of the parent function, and sketch its graph including at least 3 points. The nice thing about this one is that all 3 things that they want are already outlined for us. Here, here, and here. So let's go ahead and actually begin writing down some answers in regards to this question. So first, let me go ahead and start with the function family. Now when looking at this function family, I could automatically define that it's a cube function family. So it's a cube function family. Now the equation for a cube parent function falls like this. It's f of x is equal to x cubed, and meaning how it gets its cube features to it. Now let's go ahead and graph the parent function of this one. Now if I graph this, I'll do a small table right here so you'll see some points. I'm going to go ahead and get at least 3 points. So the points that I'm going to use for my table of x and y, or a lot of times you'll see x and f of x, will be these. You know what, that doesn't, oh, there you go. Okay, I'll use -1, 0, and 1. Now for -1, if I place -1 in here, I'll get back a -1. If I put a 0 in the x cube, 0 times 0 times 0 is 0. And then if I put a 1 in there, 1 times 1 times 1, it will be 1. So that means my 3 points will be here at 0, at 1, 1, and 1, -1. And I'll kind of have a function that looks like that. And that's how my function will look like in this case. Okay, fantastic. I went ahead and completed number 1. Okay, now that we're going to number 2, let's go ahead and read the directions. It said for the given functions f and g, find the requested function, simplifying if possible, state the domain of your new function. Now it's very important with these to go ahead and I actually automatically state the domain on both of them before we even do any kind of not compositions, but before we do any kind of manipulation with these functions. So let me go ahead and start with this one. The domain on this first one is going to be all real numbers x, such that x cannot equal, actually x can not necessarily that. Let me go ahead and undo that. The reason being is that this being a square root function means that I have to make sure that my values cannot be negative. I cannot have any imaginary square root numbers. So x needs to be all values greater than or equal to -1. And the reason being is if I go ahead and set x plus 1 equals 0, I'll find out that it's at, let me cancel that out, x equals -1, that I go ahead and I actually achieve, or that's where they actually end up being, they start being negative, any number below that. So let me go ahead and kind of undo all that because I'm going to need the space here to show you all the next one. Now for the domain on the g of x. Domain of g of x, I undo it a little bit too much. Domain of g of x is going to be, domain is going to be all real numbers x such that x cannot equal, in this case, actually same thing. Since we can't have imaginary numbers, it's going to be everything past a certain point. It's going to be everything, it's going to be greater than or equal to, in this case, it's going to be 3/2. The reason I know this is I did it in my head, but let me show you how you're supposed to do it. You set it equal to 0, and you find out the point when these numbers start becoming negative. So I solve it algebraically. I add 3. I add 3. And I find out that 2x is equal to 3, so when I divide by 2 to do my last step, I find that x is equal to 3/2. So it's exactly at this point where I find out where it's 0, and any value that's lower than this, it makes my square root negative, so then in this case, I won't be able to, or actually, that's where my domain is restricted from, because I cannot have imaginary numbers. So let me go ahead and kind of undo this part of it here. So what I'm going to do now is get into the actual, now that I know my two domain restrictions, which are very important, I'll be able to now use my techniques to go ahead and actually do the request operation, which is, in this case, multiply both. So first of all, I'll have f of x times g of x, which means I'll have the square root of x plus 1 times the square root of 2x minus 3. Now with radicals, anytime you have two radicals like this, you're able to go ahead and combine them underneath one. Since they have the same exponent, you're able to go ahead and when you're multiplying, you're able to combine them. So you really have x plus 1 times 2x minus 3 in our case. So what I'm going to do from here is I'm going to just go ahead and multiply by binomial, and I'll end up getting this. I'll end up getting, so let me go ahead and FOIL. I'll get the square root of, in this case, 2x squared. And then after that, let me FOIL this one, negative 3x, and then this one, plus 2x, and then the one with the negative 3 minus 3. I'll be able to combine my two terms in the middle, so I'll end up with this feature. What I'll have is 2x squared, and I'm kind of running out of space here. Let me see if I could go ahead and transfer this over to just a new page. So just bear with me a second. Okay, here on question number 3, we're still going to do an operation of a function. They're going to ask us to add these two. Now one thing that's very important, just like the other one, is go ahead and define the domains. This one, the domain restrictions. This first one of f of x, it's x is all real numbers such that x cannot equal, there we go, negative 1. And the reason being is that that's the only location and where that I'll end up with the 2 divided by 0, and I cannot have this. This is something that does not exist in our world, and we have to strictly prohibit it in functions or state it. In my case, in the g of x, domain is going to be all real numbers such that x does not equal positive 2. Again, this is the only location for this one where I'll have this kind of feature, and I cannot have that. So in that case, I need to state that it can't be that certain number. Okay, great. Let's go ahead and actually move into the operation of doing them. Now the first thing, this right here just really means f of x plus g of x. So which means that I'll go ahead and I'll end up with 2x plus 1 plus 5x minus 2. Now there's something very important I want to make sure you all realize. It's just like when you're adding fractions, you have to make sure you have a common denominator. So in our case, I have to make sure that I do this. I have to do x minus 2, and then over here on this one, x plus 1, and x plus 1. Okay, fantastic. So now, I now have a common denominator. I have 2x, oops, hold on a second, that didn't come out the way I wanted it to. Parentheses there, minus 2, plus 5x plus 1 all over x plus 1, x minus 2. Now the only thing I have to do is here is distribute, and then I'll combine like terms to simplify my numerator. So in this case, I'll end up getting, and I'm going to go ahead and have to open up a new sheet. Hold on a second. Let me do that. Okay, next one is question 4. It says, for the given functions f and g, find the requested function, simplify the impossible, and state your domain unit function. Okay, now this one's going to be a subtraction operation. So with this one, I'm going to go ahead and now do f of x minus g of x. Okay, great. Let's go ahead and see how that comes out. Now let me just, the nice thing about this one, you're going to do 3x squared plus 2x minus 5 minus, now it's important that whatever g of x it is, if it's more than one term, you put a parenthesis around it because we're subtracting the whole term. So the only thing we have to do is now distribute that negative, and I'll end up with 3x squared plus 2x minus 5 minus x squared plus 2x plus or minus 3. Now, I know for some of y'all that are looking at this, especially for the ones that are really catching on to this, you're probably saying, Mr. Sandoval, you forgot an important step. You did not define your domains to begin with the original functions, and you all are right. I should have defined these right away before I even started working on the problem. This one, on this function f of x, domain is all real numbers because there's no violation. There's nothing that x can't be that it's going to result in something that does not exist. There's no discontinuity in the graph. And the same thing with g of x, domain is all real numbers. So with that, I know that my answer at the end is going to be, domain is going to be all real numbers. Now in this step right here, let's go back to the problem. All I have to do now is combine like terms. So I have these values that I'll combine, these values I'll combine, and these values I'll combine. Oh, that one doesn't want to box around. Okay, there it is. Alright, so now I end up with 2x squared. Let's see, that comes out 4x minus 8. Oh, interesting. These actually might be able to factor. And if we're able to factor these, then if they do, then we have to go ahead and actually state and simplify it as much as possible. So I know I could factor out a 2, that's for sure. And actually that might probably simplify in viewing if it's factorable. So let me go ahead and factor out the 2 for right now. That becomes x squared plus 2x minus 4. Oops, actually should not use that. It's parentheses because we're factoring. Now in this case, let me think, we have to go ahead and consider what values can multiply to give me negative 4, but add up to 2, and let's see, there's only a couple of factors here, 4 and 1, 1 and 2, let's see, 4 and negative 1, 2 and negative 2, and the other way around. But the only thing is that every time I start adding them, I end up finding out that there's nothing that equates here. So in this case, I can't factor this. It's already in the simplest form. So in this case, there's my answer. And domain will just be all real numbers for this one. So this is what f of g of x is as far as an answer. Okay, great. Let's go ahead and move on to the next one. Okay, question 5. Now this one is going to require us to divide. We're taking the quotient of two functions. Now first thing, let's go ahead and define domain. Domain of f of x is all real numbers. So that's lovely. That's easy to see. Okay, let me box that. On g of x, same thing. Domain is all real numbers. That's lovely as well. Okay. Now this means we're going to do f of x divided by g of x. So I'll have x plus 3 all over x squared minus 9. Now this could be factored. And it is a perfect square. So in this case, the two numbers that are negative 9, that will give me, multiply to give me negative 9, but add up to 0, it's going to be 3 and negative 3. So I'll have x plus 3, and my two factor numbers are the numbers that came up over here, which is positive 3 minus 3. Make that minus a little bit better. Now these are going to go ahead and cancel out, or divide out, better said. So I'll be left with 1 divided by x minus 3. Now, when I define these domain restrictions, I'm going to go ahead and put down x such that x cannot equal negative 3 or positive 3. The reason I'm stating both is that if any time you run into a domain restriction, you have to include it even at the very end, just because we don't want any kind of violation anywhere in between. So in this case, in this operation of functions, here's my answer and here's my domain restriction. Okay, let's move on to the next one. Okay, here's my next one. It's question 6. It says, determine if the following graph is a function. If it is, find the domain and range, intercepts, and symmetry. Now, it is a function just because there's no, if you conduct a vertical line test, while it meets the definition, for every x, there's only one y value paired to it. And not only that, but there's no restriction, there's no violation of the vertical line test. So in this case, function, yes. Domain, in this case, my domain is going to be x values from -3 to +3. So in this case, the way we write this is, I'm going to say all, I guess the best way to put it, and you could put down x is greater than or equal, less than or equal to 3. And it's including, so that's the reason why it's equals to it. So there's my domain. My range goes from -2 to +4. So in this case, my range is all y values that go from -2 to +4. Intercepts. Quite a few intercepts in this one, actually. I'll go ahead and give you my best estimates. I'll start with we have an intercept there, 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 and there, and another one there. So in this case, I'll go ahead and say it's -2.750. We have another intercept at -1.250. I have another one at 1.25, 0, and +2.75, 0, and lastly, the one on top is 0.4. And there's and this one, the symmetry on this one is to the y-axis. There's a symmetry to this one, the y-axis. So in this case, I go ahead and I'm able to answer questions A through E. Okay, great. Let's move on to the next one. Okay, now so this one says, use the graph of the function below to find the intercepts, domain, and range intervals where the graph is increasing, decreasing, and constant. Also determine if the function is even, odd, or neither. So in this case, let's go ahead and start with the intercepts. There's really only 3 intercepts. Here, here, and there. So in our case, let's go ahead and begin with one of the intercepts is -0.275, 0. There's an x-intercept, the other one's 0.75, 0, and the last one is 0, -2. Now domain. This one exists from -4 to 3. And if you're ever really confused in this, I guess one of the things you could do when you want to do domain is think about building a frame. See how good this comes out for me. Building a frame around it. Because what it'll do is it'll give you, and my frame didn't go that well. And the reason being is that I'm writing on an iPad, and on this iPad with the stylus pen does not come out the best. But it can't be anything around here. It cannot be anything outside that frame. But if you notice the x values, they go from -4, greater than or equal to x, all the way to +4. My range values will go from -2, greater than or equal to y, less than or equal to 4. It's increasing in certain intervals. We're talking about intervals that go from, in this case, -4. Let me go ahead and show you everywhere it's increasing. Actually, I probably should pick a different color. See if I could pick a different color for this. And I'll write increasing. So line color, I'll pick it in red. It's increasing there. Increasing there. 2 places are increasing. So we got -4 to, let me go back to black so I can write this down. -4 to -3 is one of the intervals, and the other interval is going to be from 0 to 2. Okay, great. Okay, now decreasing. Let me go ahead and change the color for that one so you could see where it's decreasing. So it's decreasing there and decreasing there. Now this graph is finite, so I'm not going to be dealing with any kind of infinities or anything like that. So this one's going to have very specific locations where it's decreasing. I'll go ahead and write that down for y'all. Decreasing is going to go from -3 to -2, and the other blue will go from 2 to 3. Great. Okay, there you go. So there's my intervals where it's decreasing. Now this one is constant, and it's constant right here. Constant. And so let's go ahead and write down where it's constant. In this case, I'll be constant from -2 to 0. Now determine if the function's even, odd, or neither. Now this is going to be hard to explain it over without really showing it to you. But you're going to have to go ahead and think about, okay, if I took patty paper and outlined this outline just like what we did Flipping Awesome, and I went ahead and folded it, I knew automatically it's not going to be even. So I could go ahead and discount that. It's not going to be even. Now, if I go ahead and flip it again, it's not going to be odd because there's no way that's going to match up even after I do that. So in this case, it'll be neither. So write then neither in that spot. Okay, great. Let's go ahead and move on to the next one. Okay, great. Now that we're moving to this one, let's go ahead and this one, they ask us to determine the intercepts, domain, and range, and the values of the local maximum and minimum for the graph below. So let's go ahead and start with domain. Well, actually, intercepts. There's going to be a couple. There's going to be one at -3, 0. Next one is going to be -1, 0. Next one is 1, 0. Another one is a 4, 0. And I did not forget the one on the y-axis, which is, that's off a little bit there, which is at 0, 1. So there's all my intercepts. Let's talk about domain. Now this one, the domain, it's going to go from, like I said, it's going from -infinity to +infinity. So I'll go ahead and make lines on here because I just want to make sure you all understand that it's going from -infinity. So like this one is going to look like this, negative, greater than or equal to x, less than or equal to infinity. The range on this is more specific though. This one is going to be, it's going to be all numbers that really just go from here. It's not going to be anything below this. It's going to be all values above that value. So y is going to be all values that are greater than or equal to -4. So there you go. And now let's go ahead and state our local maximum. There's really only one local maximum, which is here. Go ahead and change the color to this so you can see the local maximum. Local maximum is the one of the intercepts, which is that one. And so in our case, it's going to be 0, 1. Now as far as local minimum, there is 2 of them, because there's 2 valleys. And the 2 valleys are there and there. Now, let's go ahead and state the first one. The first one looks to be like at -2.25 and at -1.75. And the other one looks to be at 3, -4. So there's my 2 local minimum. Fantastic. Now I got all that answered. Let's go ahead and move over. Let's move over to this very last question. And I know a lot of you are saying, hooray, yes, we made it. Yes, I am glad too. So let's go ahead and determine this. Now this one they want you to determine algebraically, which means that you have to know the rules of of how to determine a function's even, odd, or even, or let's say that again, even, odd, or neither algebraically. Now, good thing to do is to write down some of them, like in this case, f of negative x equals f of x. It's even. If it's f of negative x is equal to negative f of x, it's odd. And if it's not either one of those two, then it's neither. So that makes it easy for us. Let's go ahead and first test for even. It makes the most sense to do that. So I'm going to go ahead and do f of negative x, which means I have negative 2 times negative x to the 4th power plus 3. And I want to erase this over here so I could have room to write. So I'm going to erase this. Let's see how well it comes out. Okay, there we go. Alright, now that I erased that, let me go ahead and go back and write down the rest. 2 negative, was a negative x squared minus 4. Okay, let's go ahead and now multiply what's there. Now there's really a negative 1 that's here. That's the way I like to, well, there really is here and here. Now negative 1's 4, negative 1 to the 4th power is really going to be positive. Well, actually, hold on. It's going to be positive because you'll get negative 1 times negative 1, oops, times negative 1 times negative 1, which means you'll have a positive 1 here when you got those two negatives, and another positive 1 here, so you end up with a positive. So this ends up being negative 2 x to the 4th. Now over here, on this part right here, this is going to be negative or positive as well, because you'll have negative 1 times negative 1 because of this x squared right here. So with that, let me go ahead and write this 3x squared minus 4, which is our original. This is equal to f of x, which means that this is even. And that's how you prove it algebraically. Now, if it had failed the test of even, then you would have moved over to odd, and then it would have failed odd, then it would have been neither. Okay, great. All right, I hope you all enjoyed this, and good luck on Tuesday's test. Okay, the value that we were dealing with was, well, actually, let me go ahead and write it back down. X plus 1, and the other one was 2x plus 3. And then from there, we went ahead and said, okay, this is 2x squared plus 2x. Oh, you know, I did make a mistake here. I think it was minus 3. Yes, it was minus 3. It hadn't yet really paid effect yet, but let me go ahead and make that correction. Right here. Oops. Didn't want to do that there, but I'll go ahead and fix that as well too. Okay, so minus 3. Okay, excellent. Now let's go ahead and continue with this. I got, let's see, 2x. Oh, hold on. This kind of got all out of order for a second here. Let me go ahead and just undo some of the parts here, because what I'm going to go ahead and do is just correct it from here and then restart, because I noticed that I did some mistakes just right in there, and I'd rather go ahead and just get something clean just to begin with. Okay, it's because I just didn't do my following steps which I normally take. So that x times minus 3 is negative 3x. 1 times 2x is positive 2x, and 1 times negative 3 is minus 3. So I'll be able to combine these two terms, so I'll end up with the square root of 2x squared. Let's see, plus x, no, minus x, minus 3. Okay. Now this is actually my answer because I can't see a way to simplify it anymore. So this is f times g of x, and domain restrictions with this one. Okay, they're going to follow the same ones we had before. And that's because in our case, we figured, remember that domain restrictions carry out throughout the whole problem. So in our case, we're going to go ahead and say x is greater than or equal everything to -1, and also x is greater than or equal to everything to 3/2. And there we go. There's my two domain restrictions, and there's my answer. Okay, great. Let's go ahead and move on. Okay, now going back to this, we were right at this step, and we were going to 2x minus 4 distributed there, plus 5x plus 5. Okay, good. And then we're all over x plus 1 and x minus 2. Fantastic. Okay, now I have two like terms, here, and then the constants. So in this case, I end up with 7x plus 1 all over x plus 1, x minus 2. Now with this one, there was no change in my domain restrictions from the beginning because nothing really got changed as far as the denominator, the components there, but you have to keep in mind if there is, you got to make sure it carries throughout. Now x cannot equal the two values we said before, -1 and +2. And after that, I go ahead and found out what f plus g of x equals. So there's my answer. Okay, great. Let's go ahead and move on to the next